The inequality. How is that different than all of chapter 7 thus far? Greater than or equal to's. We could have less than or equal to's, greater than's or less than's. But what if we had all chapter? Just equal signs. Systems of equations. So why are inequalities coming up?
I don't know.
We'll see, but for right now, they're here. So, what do you see up here that is unique to inequalities that we haven't had to do?
Test the point.
Okay, the test.
Shade.
And shade. Good. Two things. Testing and then shading. Where do we shade? The true side. Now, is this a hint as to what the true side is? Yes. Knowing that that's greater than could be a hint as to which side is the true side. But didn't we just say that you're plugging in a point up here? We're testing a point. If it works, shade where it is. If it doesn't work, shade the other side. Now, that only gets weird when you have a circle. Whoa. Well, what if you plug in a point inside the circle and it works? Shade inside the circle. What if there's a point outside the circle that works? Yeah, right? Like, okay. And when we shade, it's an infinite region, so we just kind of shade to show the idea, and then technically it just keeps on going. So it's like a line. I mean, a circle, it's bounded. There's only so many points, even though there's infinitely many points inside. But so that's what's new. We're shading. So do you guys have anything fun to shade with? Color pencils, highlighters. I mean, if you have 2 or 3, it starts to get old, like your pencil. Like, okay, go this way. Okay, go that way. Okay, go. I don't know. So do you guys have anything that's colored? Like a black pen, blue pen, red pen, that works. Plus a pencil, ooh, we can do 4. If you have nothing, well, it's just going to be an enrichment. I can use all my colors. Anyway, we're coming back to inequalities. Wait, but this is a system of inequalities. How many inequalities does this guy have? Just 1. So, I mean, he's not too bad, because if I say that he's red, and then I come down 1 and make a parabola, why am I making it solid and not dashed?
Because it has a little line in it.
Because it's greater than or equal to. So that means we include the graph as part of the solutions. If it said just greater than or just less than, it would not be allowed to be on the graph, so we would make it dotted. All review from a long time ago. What's a good, easy point to plug into an equation if it's not on the boundary line, aka the graph? 0, 0 is a great one to test. And so if we test this one, we're testing this entire side. So 0, is 0 greater than or equal to 0 minus 1? Yes. And is it also a hint that, as you guys are shading this, it also happens to be the region that is above the parabola? Ooh, greater than or equal to, above the parabola. I was trying really hard to get a highlighter. Well, obviously that did not work so well. So I'm just going to use my pen. But that's just 1. What if we have 2? Well, let's make another one blue. What if we have 3? Let's make another one green. What are we going to be looking for if we put lots of them together? The overlap. We'll get back to it in just a second. Section 7.4. Where did all my shading just go? Did you just see that? It disappeared.
Yeah.
How did it disappear?
I always thought that was great.
Don't ask me. It's been possessed all morning. Okay, so possessed by a stubborn spirit. Okay, just kidding. I don't think you talked about that. Stubbornness is natural. It's not a possession. So anyway, what we're going to is systems of inequalities. What if we have more than one? And then there are some things like vertices, but basically we're looking for the overlap. I'll get back to that in just 1 second. You guys are trying to find things to shade with, and we are trying to grade 7.4 and see where partial fractions got tricky, if they did. So 7.4, partial fractions, the A's, the B's, the C's, I see them. Here we go. Number 2 is improper. Number 6 is C. Number 8 is A. Number 14 is pause. Could the test have questions where you just have to set it up? Yay! Now, wouldn't it be a bummer if you either didn't read the directions or didn't understand the directions and solved all the way on a problem that had only the setup as the answer?
Yeah, so.
Right? So on the test, what are you going to look at before you go solving? Well, the directions, or even just the multiple choice answers, because could they have just A's and B's and C's? And you're like, I don't even have to go all the way. I just have to tell you which one. Just a heads up. Because if they just have it like this, don't you dare waste time solving for what A, B, and C is. They don't care. They just want to know that you know how to set it up on that one. If there are numbers up top, well, you better solve. But anyway, there's forming the partial fractions, forming them, just getting the form of them, the formula for them, and then there's solving. Aha! Number 22, sadly not just the form of it, but the actual solving of it. Now, some of you guys might have written it like, check it. This is the same thing as 4/5, right? 1/5 on the outside times 4. And this is the same thing as 1/5, because it's 1 times 1/5. If there's something where A and B or A, B, and C are fractions, they don't want nasty fractions in numerators. So they're going to get a common denominator and pull out that fractional component, pull out that denominator. Just a heads up. Yeah, 4/5 and 1/5 is totally right. It's totally right. They just said, ew, they both have fifths? Pull that out. And they did. The other way of writing it is you could have, please don't mess up my screen. You could have also written it with the 5 down from the bottom, which I guess you could have then distributed, but how many of you guys are that, I don't know what the right word would be. Efficient? No, that. Creative, thinking apart from Calc Chat and Slater. I'm not sure, but you could have also written it that way. So with 4/5 over, 1/5 over, or with the 1/5 outside, or with the 5 in the denominator, all three of them technically work. And P.S. Jaden, this would have been a great thumb trick. See it?
Where you like cross?
Did anybody do the thumb trick on their own on this one?
I forgot how to do that.
Oh, really? You guys forgot the easy way. We saw too many hard ones on Friday, huh? You could have thought of this as x minus 3 and x plus 2. It doesn't work on all of them, but we like the easy way. Right? What's the 0?
3.
Cover and plug in 3. Plugging in 3 to the x on top. What's 3 plus 1?
4.
3 on bottom?
5.
4/5. What are we going to plug in?
Oh my god.
What are we going to plug in? Or am I covering?
-2.
-2. What's -2 plus 1?
1.
Oh,
Negative 1. What's -2 minus 5? -1 over -5 is, no, I would advise you write that math off to the side so you don't have to like hold in all those negatives and positives and take your time. But yeah, you could have done the thumb trick method. You're welcome. Ooh. Could you have done the thumb? Now, I know, they're making it look awful. I know. I would color code it. It would have been a little bit nicer. Could you have done a thumb trick on this one? Yes, because x plus 2, x minus 2. Yes, for this one. Nah, but then it's a no. Why is it a no? Can I break this one down anymore? Not while keeping it real. Keep it real, keep it real, keep it real. So, I have my yes, no. Okay, so you couldn't have done the thumb trick, but could you have done the zeros trick?
Yes.
Yes. Does anyone use the zeros trick? Anyone plug in -2, plug in +2, and then plug in a couple more random ones? Sophia, what else did you plug in besides positive and -2? Or was that enough? Yeah. Yeah, you could have done 3, or I would have done like 0 or 1 because you hadn't yet, but yeah, you could. So Sophia is saying you could have plugged in. So the rest of you guys color-coded? Really? Yeah, it works. But you would have had a system of 4 equations. Did you solve an A, B, C, D? Woo! Did it work? Did you do the rational?
Yeah, it took forever.
Yeah, but it works because there's a system. Good job. Yeah.
I mean, I did it right, but I did it over with the fractions again, so my end result was.
But don't look at this. Look, even these fractions were different though.
Yeah.
Oh, bummer. But you were getting answers and just something went wrong in between?
Yeah. I got like to a point correct, I think, but then again, so B.
Okay. And did you do your correct A, B, and then CX plus B? Like, he had just a letter, he had just a letter, and he had a line?
No, I think I did, it was like AX plus B and then CX plus B. I think that's where I went wrong.
Oh, you didn't break him up. I see it. You did one for him and one for him. Instead of realizing that he had two parts to him. Okay. Okay, that makes sense. That would have thrown you off. I'm guessing we might all benefit from seeing this one, like before the test at least. But for today, can we just keep going for a sec? Okay. Like I'm hearing this one was hard. I got it, A, B, C, D. Like I see that it's hard with all the different variables. And okay, let's be honest. Is my work gonna look just like theirs? No. But does their work show you the who all makes an x cubed? Who all makes an x squared? Who all makes an x? Who all makes the number? Color code. He would be yellow, purple, pink, and then I have to bring out like a blue. And then color coding over here would be like, well, 0 is the x cubed because there aren't any. 0 is the x because there aren't any. 0 is the constant because there aren't any. Ooh, but 1 is the x squared. I got myself 4 different equations with 4 different variables, and Cassie used the stair step and got it. The rest of you guys, I don't know what you did if you didn't do Sophia's way or Cassie's way. We'll get back to it. But then some of you are like, well, I just didn't get it right, so I'm not really telling you what I'm doing. But I get that too. Number 44, did you go back the hard way or the easier way? Did you divide first?
Yes.
It's improper because remember greater than or equal to. Or equal to. And when you do polynomial long division, you get 1 plus negative 5x minus 6. They pulled the negative out of everybody. I think it was negative 5x minus 6. They pulled the negative out. Here's the crazy thing. So they just stopped because long division was enough. Did anybody try to factor this?
Oh, I
I
Well, you were supposed to try. Like, that was the point, right? Like, break him down. He's a remainder. But when you did try, x equals negative b plus or minus square root b squared minus 4ac. What's true about that? Ooh, algebra 1, discriminant. It's a negative. Square root of a negative doesn't exist. Can you factor it? No. And since you can't factor it, just wait. It's up here somewhere. Since you can't factor it, well, then he's my... Ooh, ax plus b. It's already done. There's no way to break it down anymore. You have your quadratic and you have your ax plus b. There's no more splitting up. Well, that's a nice problem. 1 division, and I'm done. Because it can't be broken down anymore. If you hadn't divided, that would be a bummer because you would have tried to factor and then you're like, and then your ax plus b isn't there, so then you're in trouble. But if you divide, I have my ax plus b in there. But once again, just a quick reminder, that minus technically meant a negative to both. If you had that, still perfectly correct. And then I think that's it. Do you guys just want to see what 7.5 is going to look like? That whole shading thing? Yeah, I know, I hear you. Ooh, he's solid, because it's we're equal to, and he's above, because he's greater than. Ooh, you can do this on your calculator? In some ways it messes up your calculator, just be forewarned. But yeah, you can, or you can just see, wait a minute, it's less than, don't you just shade below? Ooh. But would that be right if you guys drew me this graph and that was the equation? I know the calculator shows this, but is it technically right from what you can see? Why not? Has to be a dotted line. The correct graph. Oh. Looks like a beard. Anyway, should be dotted. Correct graph should be dotted, but your calculator might not necessarily show the dotted line. Some of yours might, some of yours might not. Whoa, this one has 2 different inequalities, and I feel like the picture would be a lot messier if you had like red and then like green, and then like the solution shows the overlap thing. So what does that mean? The line was shading up. if you rearrange, the line was shading up. What was the circle shading?
Down.
In. You see it? The line was shading up, the circle was shading in, and you're graphing the overlap. So, as opposed to the ones up here that are like, oh yeah, all of that, and oh yeah, all of that. As soon as you start doing systems, they're going to say, okay, after you shade all of that and all of this, the overlap is what they're actually looking for. Okay, I just wanted to show you guys that before getting you writing this down if you have not yet. And I'm going to go ahead and steal number 36. I'm going to go ahead and steal number 36. I might just save it to the home screen if we run out of time. Because this section is not super complicated. It's mostly just remembering what inequalities mean or what they do. Oh, not 34. It was 36, right? Yeah. File save as. And then just being like, okay, so if we have systems of inequalities, we're not just looking for one point of intersection. We're looking for a whole region of overlapped shading. Inequalities aren't just one answer anymore. It's everything greater than. Let's see, partial fractions. If we don't get to number 36 today, we will get to it before the test. Probably tomorrow since it'll be a non-chapel day. And you won't, I don't think you'll have a lot of questions on homework tomorrow. Maybe a couple, but not a lot. So I have that 36 saved to the home screen. If we have time today, we can peek at it, but if not, it'll be A-okay. Sorry. Woo. You might not have seen it, but this homework isn't very long either, which is nice. This homework isn't very long either, which is nice. Okay. I was getting Calculus BC notes up and ready. And I do have your 36 in the background, but remember with Chapel Day, and with us trying to get through this section in one day, we might talk about it more. Let's also be good with the test. I don't think the test has any A, B, C, D systems that need to be fully solved. It might just be like setting up the form with the A, B, C, D in the right places, with the right denominators, but not solving all the way, but you will have an A, B, C. Which could just be A and B and C, or A and BX plus C. I think you'll have at least one or two of those. Okay. Systems, we know. Multiple conditions, multiple things that need to be true, multiple equations, but now they're not equations, they're inequalities. So we're going to sketch each inequality. I'm going to say in different colors because that makes my perception of what's going on, and it's a lot easier to handle. I'm going to say different colors. You guys try to do it all like with your pencil. Just if you get more than two, it gets really messy and confusing. Find the region in common. I'm going to call it the overlap. The overlapping region. But you also need to know whether to make it solid or dotted. So a quick reminder of the boundary lines. And then by boundary lines, I just mean the actual graph lines, like the actual parabola, or the actual line, or the actual circle. Boundary lines, remember we have it solid, oops, there we go, when we have or equal to, aka the actual graph, the parabola, the line, the circle includes or is included in the solutions. Those points are included in the solutions, but if we don't have or equal to, if you just have less than or greater than, remember those boundary lines cannot be included. Okay. But here's one term that we don't necessarily know the vertices of the solution. Maybe? Vertices. What are the vertices of a triangle? Oh, you know this, where the vertices of a triangle, or the vertex of a parabola.
0, 0.
Okay, for a parabola, good, it's the lowest point and highest point. What about vertices of a triangle? Just the corners. Just the corners. The vertices of any sort of solid or any sort of geometric shape are the corners. So what's the one common geometric shape that doesn't have any vertices? Circle. But wait a minute, what if you had, like that one you guys just saw in the answer key, a circle with a line through it, and a certain overlapped region? Does this have vertices? Yes. One right there, and one right there. So who are vertices? How do those sharp points happen? The intersections. Good. So the vertices are going to be the same thing as the intersections. And haven't we been talking about how to find intersections of systems of equations all chapter long? The vertices are the intersections. Which, if you only have two equations, no big deal. Set them equal to each other and then, or solve the system of equations and you'll know your intersections. If you have 3 or 4, well, we'll just deal with it when we come. But the vertices are the intersections, and those are kind of like the boundary points, or the corner points. You can think of them as corner points, if that helps a lot. But long story short, we just need to get to some examples, yeah? So, do you have your shading out, or your shaders ready? Whatever you're going to use to shade. Let's see what we have coming on the next page. Some of you might still be able to see that if you need it. We have 3 inequalities. Oh, gross! 2 of them are lines. Actually, all 3 of them are lines. Which one's the most normal line out of all of them?
Actually, y.
Yeah.
Y.
Because can't you rewrite this to be y is greater than x minus... Whoa, how'd she do that? Didn't I add the y to the other side, which is why he's on the greater than side? And didn't I subtract the 2? So the y is greater than x minus 2. There are different ways of doing it, but some of you, if you do it the other way of subtracting the x, need to remember when you multiply or divide by a negative number, the inequality will flip. But now I graph my y-intercept of being negative 2, going up 1 over 1, up 1 over 1. I don't know, we have a lot of up 1 over 1s. I can graph my intercept. My up 1 over 1, my up 1 over 1, my up 1 over 1. But why am I connecting it just with a dotted line? It doesn't have a line under it. Yeah? So all the points on this line are illegal for this inequality. So what points are legal? In our notes, we said test and shade. I see 0, 0. I see him not on the line. I could have picked any point out here on this side or any point out here on this side, but 0, 0 is an easy one. If he works. Is 0 greater than negative 2? 0 greater than 0 minus 2? Yes. So therefore I'm going to shade on this side. But guys, it's also usually enough to look here. Y greater than means y's need to go above, right? Y greater than means y's need to go above. Now he's working hard. Nope, he's not. Yes, he is. So therefore the line is going to be shading everywhere up. Yeah? But what else do I have? Wait, I can't rearrange him. Where's x equals negative 2? Isn't that like on the x-axis? Yeah, so x equals negative 2. Well, x greater than negative 2. I see to get to negative 2 and then extend that line, but why am I making him dotted? Because once again, not or equal to. But wait, what's above a straight up and down line? That's why we test. Test 0, 0. Is it 0 greater than negative 2? Yeah, 0 would be, 1 would be, 2 would be, 5 would be. All of the ones on the positive side are higher. All the ones on the negative side wouldn't work, would be lower. So hence why I'm going to go ahead and shade everything to the right for this guy. You guys see the triangular overlap, yeah? But we're not done yet. What else do we need?
The horizontal line.
Horizontal line. And Alec, why are you saying horizontal?
It's on the y-axis.
Because y equals 3 is a horizontal dash. And so I just need to extend that one. Wait a minute. Why am I making it solid? Good. Because what does it say? But where am I shading? What? Doesn't it say less than? So we could plug in 0, 0 again. 0 is less than 3. So yeah, let's shade where 0, 0 is. Oh, that's a lot thinner than I wanted it to be. It's going to get thick. Now, at this point, you're like, oh, crud. Right? Oh, yeah, see? Like, so many different shadings of ends. Which is why I say come back and reevaluate and see if you can find the region. That's technically being described. Now, check it. Why am I going to come over here and get a little baby eraser? Get a little baby eraser. And why am I going to erase that vertex? Oh no, I need to totally erase. Oh, it's not erasing. How awkward is that? That vertex, and that vertex, and this vertex. Why am I erasing right around where those vertices are? And why am I going to come back over here, and why am I going to draw little open circles?
Because they're inequalities.
Well, they're inequalities, but this guy's an or equal to. So isn't he allowed to equal? Yes, but who's not allowed to equal?
The guys
The other guy. Isn't he allowed to equal? Yes, but who's not allowed to equal? And neither of them are allowed to equal. So technically my region is going to be this right triangle where all three colors overlap, but each of my vertices are blank. Now it says to label the vertices. The nice thing is, if you guys were keeping track of what we were doing, maybe you could label these pretty easily with, well, this one, y was 3 when x was -2. This one, x is -2 when y is, oh stink, I don't know. I think I have to plug it in, plug it in. Oh my goodness, we're going to be practicing substitution. -2 minus 2, that's going to be -2, -4. We're going to have to kind of just think of red and blue to get this guy. Think of blue and green to get this guy. Well, y is 3, x is, well, I don't know, plug it in, plug it in. -3 plus 5, that must be 3, 5. So you're kind of be playing with systems of equations, because when you get to a vertex or a corner, you have to take those two guys and say, who's your intersection point? Red and blue. Who's your intersection point? Green and blue. So you're going to be plugging in to find like the x or find the y, whatever it is you're missing. I think I have like a nice picture of it on the next page as far as what the answer key would show. Do you guys see how they're pretty much just getting the overlap but then showing those little empty circles? Just realize that this came from that, yeah? Finding that overlap and then being like, there you go. There you go. Now, what else is up? Wait. Up. Wait. That's it? Now, what else do you think you're going to see besides lines in homework? Circles, parabolas. You should be graphing a lot of different things. Yes. But in this section, guys, I would have you guys be more concerned by the overlap and finding the overlap and finding the vertices than by needing to graph everything by hand. Meaning, the test will have two parts. Calculated part, non-calculated part. This would probably be calculated part if it was any of those messy graphs, as far as like parabolas and circles, etc., because it would be easier to find those intersections on your calculator since it's like a problem with lots of steps rather than without. And just in case you're curious, as far as, well, like, what else could this chapter do? We're not going to spend a lot of time on this, but it is a profitable just kind of peek and introduction to you guys. This is kind of getting into like business and econ a little bit. It's pretty more business than accounting. It's the idea that in the real world, when you're talking about constraints for a business, it's not necessarily like it has to be on this line. It's usually like as long as it's above that, I'm good. And as long as it's below this, I'm good. Like you have a max of what you can spend or a min of what you need to make. Does that make sense? So it's kind of trying to at least be like, okay, we've been doing systems and that's great and all, but to be more practical, it's actually a bit more complicated and inequalities get a little bit more realistic. Now, with all of that being said, you guys see we have a few minutes, yeah? Oh, don't worry, that's Calc BC. Don't worry. Breathe. But what do I have over here?
Number 36.
I'm not going to do the whole thing, but remember, there are two approaches. This one is using the zeros, and this one is categorizing by like term. Categories of like terms. Both of them technically start out the same way. Both of them say, can you factor? And the full factorization is going to be that little x plus 2, x minus 2 times x squared. Let's think that was minus 4 plus 2, I think. And having that, okay, I have my, and then I have my, and then I have my numerators over my denominators. Remember, this guy is a linear because he's a step or an irreducible quadratic. And so both of them technically say, whichever direction you're going, we want to look at what happens when you get rid of the fractions, except the categories and the like terms say, I'm not just going to look at it as 1x squared. I'm going to look at it as 0x cubed plus 1x squared plus 0x. Because technically, all of these terms are involved when I do all this multiplying. When I multiply, I get a times all the other denominators. I get b times all the other denominators. And I get cx plus d, sadly, times all the denominators. Why did Sophia go to zeros? Because the way that Cassie did with, okay, the x cubed are the blue ones, and the x squared, I'm not saying that you color-coded, but I would have. This guy is like the purple ones, those are the yellow ones. You would have had to have multiplied and FOILed all of these out to figure out who all is my x cubes. Okay, you go over there. Who all are my x squareds? Okay, you go over there. You would have had to have multiplied it out. That's the categories over here, the like terms, the color coding. You would have had to have grouped to make 0, 1, 0, and 0 after you would have had to have multiplied. Hold on, give me 1 second. Over here we say, nah. Let's plug in 2 and see what happens. Let's plug in -2 and see what happens to every single x. My advice, let's plug in 0 and let's plug in 1. Why? Those are zeros. I see them right here. These guys are just easy to plug in. And then you don't have to multiply it out. Ponder it tonight in case you guys click on that one. I'll see you guys later. Plenty of fun thought brownies. You guys need to come back and get some chocolate specimens for lunch or on your way up.
Oh? Yeah. Wait, so you got a bring the bottle?
Standing by here.